OpenSSH workshop where you do the work and I try to help. My name is Joost van Dijk. I work for Yubico. Yubico is actually, can everybody hear me? Because I can use a microphone, but I think it should be possible, right? So we create security keys, and security keys, that's what FIDO is all about. It's a standard for having secure hardware to store private keys and to do authentication, signing, etc. So one of the use cases is OpenSSH. I'm not affiliated with OpenSSH project, but Yubico is a member of the FIDO Alliance, so that's my point of view. So I don't have anything. I'm not an expert in OpenSSH, but I'm supposed to be an expert in FIDO. So this workshop is about the combination of OpenSSH with FIDO, which is possible since I think 2000. So most of the distributions should be recent enough OpenSSH version to use a security key. Who has a security key? Quite a number of people, but I brought some, so everyone that doesn't actually, everyone that wants one can take one from the box. I just have a limited amount of USB-A. Most of them are USB-C. That's what most people use. Anyone who doesn't have a USB-C port? 1, 2, 3. So I have some USB-A. So I'll just pass this box around. Take one if you like one. You can keep it. I don't need it back. So I'll just pass it. Take one. And so if you can pass this around for the USB-A. So these are actually not YubiKeys. They're called FIDO security keys by Yubico. So it's not the full-fledged YubiKey that has all these different applications. It only has FIDO. But as this is a FIDO workshop, that's all we need for this workshop. So YubiKey is a little more, but this will do for here. Yeah, everyone that wants to use it has one now. I prepared some exercises. Fortunately, I just remembered to publish them on GitHub. So there's the Yubico Labs organization that is for non-official Yubico software. If you go there, there's a FIDO OpenSSH workshop, and I put some exercises there, and also a Python tool to do something for one of the exercises. So please access this repository. You can clone it if you would like to have the Python tool, but you can also read the exercises just from the web page. So I do assume OpenSSH knowledge, so if you know about what a public key is, etc. But I don't assume any knowledge about FIDO. So the idea is that we have like 6 quarters. So the first quarter I'll talk about FIDO, so what FIDO is, in a fairly generic way. And then I have 5 exercises. So let's say that we have 15 minutes for each exercise. And we just take 15 minutes. But you can do it on your own pace. You don't need to move to the next exercise if you didn't finish the first one. So, but every 50 minutes I will just take questions and well, you can tell me what typos that I made and what doesn't work, so I can fix it. But because you have the honor of being the first to do this workshop, so I created this for this event. But I hope to give it more often. So if you have any feedback or typos or just plain errors, then please let me know. One of the exercises assumes a GitHub, but it also works with GitLab, if that's your thing. And of course, you need a security key, well, obviously. So the prerequisite software for this workshop is listed here. You should have had an email with this information, but if you didn't get that or you arrived late, this is the... Yep.
Sorry, just remember to use the mic for the recording.
Oh, it's being recorded? Actually, I didn't know. I'll use the mic. So sorry, I didn't know that it was recorded, so I'll play full start. So this is the software that is required. If you don't have anything of this, like Docker and Python, Docker we use because often I don't know what the Wi-Fi is at the venue. Here it's actually quite good, so we could have used something else, but this is just to be able to have like a standalone SSH server running on your laptop. Let me put the microphone on, like this. Sorry. So yeah, so this is also listed on the GitHub page if you still need this slide. So for the next 10 minutes or so, I'll talk about FIDO. So FIDO is many things. It's a number of specifications, and it's also an organization or a project. So there's this thing called the FIDO Alliance, which is a consortium of organizations that intend to basically eliminate passwords and eliminate phishing. And the primary use case is authentication on the web. So usually you use it in a web browser or maybe on in your operating system. But you can also use it for OpenSSH, so that is what we're talking about today. So as an overview, I'm going to introduce you to some tools that you can use with your security key to see what's stored on it, for example. And we're going to use that in the exercises. And then I have 5 exercises. So the first one is the generic one about creating keys. How do you do that? What are the different ways of creating keys? Because you have many options to do this. So what are the differences, and when do you use what option? It's a fairly extensive exercise, so I'm not sure if it's going to be finished in 15 minutes, but if you don't, I'll just continue in the second block. Then OpenSSH also supports signing, so you can actually use a key to sign things like files. So that's what the second exercise is about, signing things, but it is mostly used for signing things like Git commits or tags. So that's the second exercise. Then we have something called large blobs, so explain what those are. But those can be used to store an SSH certificate on your security key. I often say YubiKey because that's what I'm used to, but nothing that I talk about here is specific to YubiKeys or security keys made by Yubico. It's a standard, so any vendor should be able to, you should use any security key by any vendor to do these exercises, except perhaps for things that are optional, so like large blobs. Large blobs are an extension of FIDO that is optional. You don't need to implement it if you're a security key vendor. So the SSH certificate exercise can only be done with a vendor that supports large blobs. But that's also many vendors that do so. Then there's a thing called device attestation, which means that you can actually prove to someone else that your SSH key was generated on secure hardware, so on a security key. And that is, for example, useful for if you have like an SSH certification authority. So you can, maybe there's a policy that the CA says, well, I will only sign your public key if I am guaranteed that it is generated on secure hardware. So that's what device attestation is about, and I have some examples there and an exercise. And then SSH agents is often used for like an SSO experience for public keys, but that's not really useful with security keys because SSH agents will load your private key into memory, but that's not possible with security keys because the security keys are not exportable. You cannot export them and load them in memory. So often you're not using a passphrase to secure your files because that's secured in a different way. Yet there are examples where SSH agent is actually useful with security keys, and that is what the last exercise is about. So that's a bit of an intro. So let me also talk a bit about FIDO itself, so the FIDO concepts. So there's actually 2 specifications that are relevant. The first one is the most well-known one. It's called WebAuthn. But that is specifically for the, or mostly for the web use case, where you use something called a passkey these days. So passkeys, they're just FIDO credentials, specific kind of FIDO credentials, and they're mostly used on the web. A couple of other examples as well, but the other specifications is actually what we're using in OpenSSH. It's called CTAP. CTAP stands for Client to Authenticator Protocol. So the authenticator, that is, in this case, a security key, so a USB device. And you have a client that needs to communicate with that device, and that is done with this protocol called CTAP. So CTAP is what OpenSSH, the client, implements to talk to a security key. So two specifications, and yeah, let's see how they differ. So here's the web use case, where we have an underlying party, so let's say a web server. We have a client, so on the web that is a browser, and we have an authenticator, and in this case that's a security key. So the private key is stored on the security key, the public key is stored on at the underlying party in the account of the user. And so this thing called WebAuthn is actually what is used by the web server to run on the client to interact with the security key. So it is a JavaScript API, typically for code running in your browser. So that's not really applicable to the OpenSSH use case. CTAP, however, is then implemented in the client. So in this case, a web browser. So all modern browsers have an implementation of CTAP so that they can communicate with security keys. So Firefox, Chrome, Edge, Brave, etc. So let's now look at the SSH use case. So we have, again, a client and a server. And now the client, the OpenSSH client, is the one that uses CTAP to communicate with that authenticator. But there's no such thing as WebAuthn that is used in OpenSSH. And actually, the SSH protocol is not really modified. The only thing that is modified on the server is that the signatures that are created by the security key are a little different. So the server needs support for FIDO, in that they need to be able to verify signatures that are created on a security key. So there's new key types, and we'll see that in the first exercise. But for the rest, it's actually quite similar, but it's only CTAP. So why would you use FIDO with OpenSSH? Well, the goal is to protect your private key, and there's actually different ways to do this. FIDO is not the only way. You also can do this with PGP. So if you have an OpenPGP smart card, that also works because you have this PGP agent that can act as a SSH agent, and that is a popular way to interface with secure hardware. And there's also this thing called PKCS 11, which is a standard for talking to secure elements like HSMs, and that works with a driver specific for the hardware that you're interfacing with, and that also works. And so that is implemented in OpenSSH with a flag. You can just query an HSM or something for keys, and then you can use those keys for signing things. So why would you use FIDO? Why yet another way to sign things with OpenSSH? And it is because it's much simpler, especially if you compare it to PGP. I have many colleagues that use PGP, and they're Yubico employees for a long time. But we have a specific Slack channel for problems with PGP because it's such a nuisance at sometimes to keep it working, actually. So, but of course, if you're a PGP expert, there's no reason not to use PGP, but especially for people starting with secure hardware, FIDO is much, much easier. Also, compared to PKCS 11, PKCS 11 is a bit of a problem because you need a PKCS 11 module by the vendor of your secure hardware. So it's not built into OpenSSH. You still need additional software. And also, in some use cases, you don't want to have copies of your private key. So it is not a standard way. There's no standard way for OpenPGP and PKCS 11 to prove well, PGP doesn't have something, but that does not work with OpenSSH. So for the OpenSSH use case, it's not possible to prove that there are no other copies of the private key. Because you can import keys and export keys, both with PGP and with PKCS 11. And that is not possible with FIDO security keys. So if you generate a key on a security key, FIDO security key, you cannot export that key. And if you want to have true multi-factor authentication, then you actually need this property that you cannot make copies. Because if you can make many copies, yeah, then is that still a possession factor, you may ask yourself. Because you can just export the key, store it in a file, and yeah, that's, in my opinion, that's not MFA. So let's have a look at FIDO. Yeah, question.
So the attestation in the PGP is different from the attestation in the FIDO?
Oh, so the question is attestation different for PGP than for FIDO? It is different. I must add that for PGP, if you use a YubiKey, you can actually do attestation using PGP. But as far as I know, you cannot use that in this context, because it's not built into the standard and the tools. And you can do this with FIDO. All right, so I'm not going to go into too much detail, but this is about the flow of the CTAP messages exchanged between the client and an authenticator. There's actually only two operations. One is to create a credential, and the other is to use a credential. So create a credential just means generate a private key, and the other operation is get assertion, which simply means sign a challenge. So that is actually the information that is exchanged in the CTAP protocol. And the state maintained between the client and the authenticators, well, the client will need the public key so that the keys that are generated during a make credential can be, so the signatures made with that key can be validated later on. So that's the client typically stores a credential ID that is just a handle for the key. The public key itself, and some other data that is not so relevant here. The authenticator can store these, of course, it can store the private key, but it also associates some other data with that private key, most notably the relying party ID. So the reason is that on the web, a FIDO credential is scoped to the web server that you're using with. So if you're signing into github.com, your browser actually checks that you're using a key that is specific for github.com. So if you go to a phishing site, the relying party ID won't match because it is retrieved from the URL of the server. And then you cannot use this key because so your browser helps you making mistakes. And that is the phishing protection that is part of FIDO. So we don't have that problem in OpenSSH. OpenSSH is already phishing resistant, you could say, because there's a host key check. You have this trust on first use mechanism. So the relying party ID for OpenSSH is a default constant called SSH. But we'll get to that later. So there's data stored that you can store on an authenticator. We'll see later that you can also do that differently so that you can have an infinite amount of credentials on a security key. Yeah, that sounds impossible, but we'll get to that. Okay, then there's a lot of terminology in FIDO, so that's the reason for my intro. So I already mentioned authenticator. Authenticator is simply something you can use FIDO credentials, store FIDO credentials on. So a security key is an example of a FIDO authenticator, but there's many different authenticators. But a security key is what is also called a roaming authenticator, because you can move it from one system to another. You can keep it in your pocket and move from one system to another and sign in. And that's, yeah, a cross-platform authenticator. There's also a platform authenticator. Those are built into your system, and it's, for example, on your iPhone or your Android device or on Windows. And uses the same technology, except that the the property that you cannot export private keys is lost there. So if you heard about passkeys, most people talk about passkeys in the context of Apple and Google, and they synchronize private keys during their, using their cloud environments. So you actually have copies of your private keys. So that's the biggest difference between a FIDO security key and a passkey stored on, let's say, your iOS device. So both are phishing resistant. So passkeys stored in the cloud are still phishing resistant, but they're not truly MFA. Question?
Yeah, I see Bluetooth Low Energy. Is it specified in the FIDO standard? And are there some existing implementations or something like this?
Yeah, so the question is that the transport, so we're using USB authenticators here, so security keys, USB security keys, but there's actually, in the specifications, there's different ways, so different transports. So NFC, obviously, because you want to use your NFC scanner on your phone to do the same thing. And there's also BLE and hybrid. So BLE is, so there exist authenticators that use Bluetooth, but it works horribly, and I think recent browsers don't even, they probably dropped it. And it is because now they use hybrid. So hybrid is something else. It's when you scan a QR code using your phone. So for example, if you go to GitHub, one of the exercises is with GitHub, if you register a passkey there, and you decide not to use a security key, but your phone, you can actually scan the QR code. And of course, scanning QR codes is scary. And that's why Bluetooth Low Energy is used in the hybrid transport protocol to make sure that the phone that you are registering or creating a signature with is close to the client. So if I scan a QR code on my laptop from my browser using my iPhone, there's actually a Bluetooth connection between my laptop and my iPhone to make sure that someone in, let's say, China is not able to phish it using that QR code, because the hacker is then not in proximity of my laptop, or sorry, my iPhone. So they cannot set up a tunnel to do the CDAP protocol. This is completely irrelevant for OpenSSH, by the way, but it is interesting technology. So it's not completely phishing resistant, but let's say you reduce the number of possible attackers from 7 billion to, well, in this case, 20. A little more probably, but yeah.
Is this the same technique I've seen here in the subway, the metro, where you can use your iPhone scanning a QR code and doing some, just getting in the subway?
No, that is, actually I'm not sure what they're using here. I should know because I live here, but
I've seen
it's not
some
passkeys.
QR code and doing some things and doing some NFC or whatever.
Actually, it's a good question. I don't know. I don't think it's FIDO, but I could be wrong. No. Because our railway system is not that innovative, so that's why I think no. Anyway, that's authenticators. As I said, this works with any security key. So, of course, I have put some YubiKeys there, but there's many other vendors. There's actually also open source vendors. So you may have heard of Solo Keys. It's open hardware, so it's not as secure. Well, that's me with my marketing hat on probably, but yeah, of course, it depends a bit on the secure hardware, like the crypto processor. Is that so? This is an open source project, so they use different hardware that you don't need an NDA for example. I think it's a really interesting project, but it's yeah, different. So we're not going into that, but there's actually so the FIDO Alliance also has certifications. So there's different levels of certifications depending on how well the private keys are protected. So if you want to have like really cutting edge security, you can go up to level 3 to make sure that there's tamper resistance and all that. But it's not a requirement. So you shouldn't make private keys exportable, but yeah, there's different amounts of effort you can use to prevent that. Here's a title key by Google. So Google is also a vendor. Under the hood, there are actually function keys, like on the lower left. But these are just a couple. There's actually many more vendors. We'll see that later. Some other terms that are relevant for this course: user present and user verified. So it's not just about storing your private key on the security key. You can actually require some user gestures, and that's typically why there's a button on the security key. So it is to prevent some rogue process running on your system signing something without you knowing. So actually, before the private key is being used to sign something, you're required to touch the button. So there has to be a user present to touch that button, or press it, depending on what kind of button it is, to be able to authorize the signing operation. And that is, of course, anyone can touch a button. So if you think, okay, but I want only me to be able to touch that button, then you can actually either use a security key with a fingerprint sensor, so that you can enroll your fingerprint, so your fingerprint needs to be recognized before you can do this. And on models that don't have a fingerprint scanner, you can also do it with a pin. Another question?
User presence in bracelets, it says UV.
Oh.
UP?
Yeah, you need a reward. I'd say I give you a free security key, but I think you already have one. But yeah, thank you. Yeah, this is UP. So there's UP for user presence and UV for user verification. Thank you. Yeah. Copy paste. So you can use this for your OpenSSH key. So if you're worried about some process signing into your SSH server without you knowing, you can do that either with user presence or even stronger with user verification. And we'll see that in the exercises. Then I said something magical about infinite amount of keys. And that is the difference between resident keys and non-resident keys. Actually, these days they're called discoverable credentials and non-discoverable credentials, but I don't really like that name because, yeah, resident keys is actually what it is. It's stored in memory on the security key, and a non-resident key is not stored, so it doesn't cost any memory. And the idea is that there's like a wrapping key on every security key that can be used to encrypt a private key together with some other metadata and use that as the credential ID. So I already mentioned you have like every credential has, of course, a key, but also a credential ID to refer to it. Okay, please sign something with the key referenced to by this credential ID. And the trick is that you can actually wrap the private key using that wrapping key to obtain some opaque blob and use that as the credential ID. So if you later say, okay, please sign something with this credential ID, the wrapping key is used to decrypt the private key and the other data that is necessary. So this means that actually the private key is sort of stored at the relying party or at the CDEP client. So stored at your SSH client. Question?
So in the second case, the non-resident, you mentioned the domain binding.
Mm-hmm.
How do you store that?
Yeah, good question. So the domain binding, where your key is scoped to a relying party, that's actually also part of the data that is encrypted using that wrapping key. So it's the private key plus some other data, so that if it's decrypted, you cannot use it at a different relying party because then the relying party ID doesn't match. I must add that for OpenSSH, because the same relying party ID is used, this doesn't work. But as I mentioned, the phishing problem is solved in a different way in OpenSSH. But for the web use case, this is exactly what happens. Here's a screenshot of Chrome. If you want to see what's on your YubiKey, or your security key, sorry. You can actually go to Chrome settings security keys and click on sign-in data, and it will use the CTAP protocol to retrieve all the resident keys stored on your security key. So in this case there are two, one for SSH and one for a website called demo.yubico.com. Of course, the non-resident keys cannot be viewed here because they're not stored on the security key. But this is good to keep in mind. All right, another screenshot. This is GitLab. Is it? GitHub, sorry. Where you see that you can actually also use it on the web. And that is, you can do that in one of the exercises. And the reason I'm mentioning this is because if you use GitHub, you can actually sign your commits using the private key that's securely stored on your security key. But yeah, you need to register the public key in your GitHub account. And if your GitHub account is only protected with a password, then that doesn't make sense. So if you use commit signing, also use a passkey to sign into your account. Otherwise, someone will sign into your account with a password that is leaked and then add their own public keys. And yeah, then there's a lot of effort without any gain. If you want to see attestation in action, so we have this website at Yubico because yeah, some people they buy a YubiKey and they want to know, is this a real YubiKey? So we have a website, yubikey.com.genuine, and it will tell you if it's a YubiKey or something else. How does that work? Well, this is one of the use cases of device attestation. So you can actually prove this is YubiKey, and that is because every security key, so not just YubiKeys, every security key has an attestation key. And that is not unique to that specific security key. It's, there's a requirement that at least 100,000 security keys need to share the same attestation key. And it is done to prevent tracking. So you don't want to be tracked by that attestation key. But it's not for tracking, it's for proving that you're using a specific make and model of a security key. So in this case, if you want to prove it's a YubiKey, you can do that on this site. And other vendors will also have a site that, and how it works, they will just register a key and ask for an attestation. And the attestation is just a signature over the generated public key, accompanied with an attestation certificate. So to prove that the public key that you're using to validate signatures is signed with this attestation key, and the attestation key can be verified using a traditional PKI, because there's a root CA somewhere that issued the certificate that is also stored on the security key, and that you can use to verify the chain, so that you know, okay, this is a certificate that is valid, it is from Yubico, which means this security key is from Yubico. Or if it's a certificate by Google, then it's probably a Titan. And this is how it works on the web, but we can also use this in OpenSSH. Question?
I see the firmware version displayed on the website. I have all the firmware versions and this one attestation certificate each? Or?
Yeah, so the question is, the firmware version, is that part of the attestation? And the answer is yes. Yeah. So what we do is, if we have new firmware, we generate a new attestation certificate specific for that firmware. And there's an exercise where you can actually look up the correlation of the attestation certificates and the firmware versions.
So you mentioned that there is a requirement of a large number of devices to have this attestation key. Is that the standard requirement?
Yeah, so the question is that a standard requirement that there's at least 100,000 keys sharing the same attestation? So security keys sharing the same attestation key? And yes, because the design goals of these FIDO security keys is privacy and security. So this phishing resistance is a very important design principle, but also privacy. So you don't want to be tracked by your security key. So if you for example, use a traditional PKI certificate, you can in the old days, you could use that certificate to sign in everywhere. But everywhere you signed in, people say, "Ah, this public key, I've seen that before." That is because your public key is like a super cookie, and this is prevented with all the privacy measures in FIDO.
So if you're your own organization and you want to bring your own attestation key, you have to buy at least 100,000 devices in order to follow the standard, right?
No, it's not about buying devices, it's about for vendors. So vendors need to produce security keys, but they cannot say, okay, I make 10 security keys all with their own attestation key, because then you can distinguish these keys. So the requirement is that if you have the same make and model, you can use the same security key. And if you want to, so you can have the same attestation key, and if you want to have a different attestation key, well, you have to make sure that you're using it enough to be able to not be able to track using that attestation key. Yeah. Question?
For vendors with updatable firmware like NitroKey, is their firmware part of their attestation?
Yeah, so the question is the firmware part of the attestation for Nitro keys which have updatable firmware? And I must say I don't know, but I think not. So there's always this question. So what happens if you have new firmware? Can you upgrade your security key to have new firmware? And then it depends. So it is not a requirement for firmware to be upgradable or not. But it's a security thing, because it's quite hard to have upgradable firmware in a secure way. Because if you can upgrade your firmware, someone else can as well. So our customers usually don't want upgradable firmware, because then they never know what's on there. But it's not illegal, and I think I haven't looked into this. It's actually an interesting question, but I'm not sure what NitroKey does. I do know that NitroKey uses the firmware based on the solo key, because what's his name, Jan from NitroKey, he sponsored this open source hardware project, Solo Keys, and he was using that firmware, that quote for his own security keys. I'm not sure if that's still the case, but Solo Keys, actually I don't know the answer for Solo Keys either. Good question, I don't know. I have to look it up, but I suspect not. Another question.
This is probably a lot easier to answer. I just noticed everything just works. I just plugged it in and Chrome can connect to it, and I can use the key. I do see that the kernel recognizes the USB device, and I can see there's a UDEV rule installed with the FIDO package. Is that it?
Yeah, so thank you for this question, because that is one of the nice things about FIDO. So if you compare this to some other smart cards, for example, where you need scary software from vendors to make it work, because you need the drivers, and they were always out of date. Another design principle of FIDO security keys is that you should not use additional software from vendors. It should just work. And this is done by using the HID USB profile. So USB HID, that is typically used for keyboards and mice and things like that. But it is actually quite versatile. And what happens is that the CTAP protocol is wrapped in sort of keyboard packets. So the information is exchanged using USB HID. And almost every system out there has an HID driver to be able to, well, usually used to transmit characters, but you can actually also transmit fragments of the CTAP messages. And that is why it's actually, you can use it automatically. And the UDEV rule, that is typically installed by your distribution, because many people use security keys, and they say, okay, well, if you plug it in, I'll make sure that you don't need to be administrator to use it. Because, yeah, you cannot just use USB HID for anything. For security, it is often required to have root access. But the UDEV rule is made sure to configure UDEV to not require root. So, yeah, it just works. It should just work. So I've never seen actually that it doesn't work. Yeah. Good. One more question. Can you use the security key on a mobile device? Yes. Not for OpenSSH, but you can use it on the web if you have an NFC scanner. And of course, the security key itself also needs NFC, or it has to have a matching USB port. So Android devices and modern iOS devices these days, they have USB-C, so then you can just plug it in. It's not the most user-friendly way. So usually you use an NFC, the NFC scanner in your phone, and then the CTAP protocol is transmitted over NFC. There is a caveat, because Android phones, they don't support pins over NFC, only over USB. So if you have an Android phone and you want to use a passkey on a security key that is protected with a pin, that doesn't work yet. But we're working with Google to get that resolved, or try to get it resolved. Yeah, so in principle, yes. Okay, I think I'm running a bit over time with my first quarter, but I think I'm almost done. One tool I want to mention is libfido2. It's a FIDO2 library written in C, and it's actually what OpenSSH uses internally. So if you install OpenSSH, this library will be installed because it is used by OpenSSH. It also has some tools, and that is useful for the exercises. There's a FIDO2 token tool that you can use to inspect what's on your YubiKey. So that's why I just want to mention it. There's also a Python module. We're actually also using that in the attestation exercise, but yeah, just for your information. And this is an example of what the tool does. It lists some properties of your security key. It does need a device file. So this is macOS, so that's why it's a weird IO-rec thing. On Linux, it's typically /dev/HID role 0, 1, 2, etc. And on Windows, it's even funkier. Cannot remember exactly what, but so the -L is just used to list all the security keys connected to your system. In this case, it's just one. And then this file handle is used to refer to that particular YubiKey. So if you have two security keys inserted, then you will have two lines of output. And well, I'm not going to explain what you're seeing here. It's a bit cryptic, but in the exercises you'll peek into this information to see what's supported on your security key. Let's get to the exercises, because that's why we're here for. So this is the FIDO OpenSSH workshop repository. Let's go to the actual page. Well, what? So there's some yada yada about the requirements, but the exercises are in the folder exercises, and there's 5 exercises. So, well, I already mentioned what the idea is of these exercises. So I would say it's now 10:02, let's say. So let's spend at least let's spend 50 minutes on the first exercise, and then I'll ask if there's any. So you can ask me, of course, during these 50 minutes to help. I'll have some concluding remarks to introduce other exercises. Let's say at 10 past 3.
Can I also?
Yeah. Oh, yeah. Sure. I have plenty of keys. What did I do with them? Oh, there. So you can keep them. I don't need them back. So. You're welcome.
One question on the previous slide.
Yep.
So, you were showing that you support EC keys, right? So with the quantum computing and the possibility of hacking, are you trying to operate the cryptography?
Excellent question. So we have these quantum computers coming, and the security keys these days, they have like elliptic curve, like ECDSA signing algorithms and ED25519. And these are all vulnerable to a quantum computer. So the question is what you're going to do about it. Well, the answer is the FIDO Alliance is looking into this because, yeah, we need to do something. But there's one additional remark, and the acute problem is for encryption, because you have this concept of encrypt now, break later, where adversaries are collecting encrypted data, and as soon as the quantum computer is here, let's say that's in 10 years, I think it's longer, but let's say in 10 years, then they can decrypt everything that was encrypted. But this is for signing. So ECDSA and ED25519, those are signing algorithms. And that means that when this computer is here, the quantum computer is here, then the quantum computer can fake signatures. But that's a problem when the quantum computer is here, because yeah, my security key, I'll just change my keys with a quantum secure version and revoke or remove all the keys that are not quantum secure, and I'm done. It sounds more easy than it actually is, but it's not as acute. But the FIDO Alliance is looking into suitable algorithms, and suitable means short enough to be usable over NFC, small enough to be stored as a resonant key, and there's many options. So this will come, but we as a vendor cannot do this on our own because it has to be according to a standard. So it will be solved, but I'm not sure yet exactly how. I saw another question here.
Yeah, sorry. So with two things. One, is it possible to get a record slides?
Oh.
Second, I cannot for the life of me find this in the output for
Okay, and what you're using the security key by Yubico?
Yeah.
Okay.
It's on it's on
Okay. So the first question is, can we get a copy of the slides? Answer is yes. I'll add them to the repo. Second question: what about the min pin length?
I can see it up there straight away, so I thought, oh, maybe it's to do with I can have a pin already set.
Yeah, it depends on the version. So is that the YubiKey that from yeah? And can you see the firmware version? Because if it's 5.7.4, so major minor build,
yeah.
That is our latest firmware, and it should have the max pin length column 4 there. If it's not, then you probably have an older version of the FIDO 2 tools.
Okay.
And I didn't think of that, sorry for that, but I think the latest version is 1.16. So if you do FIDO 2-token-V, I think capital V, it will tell you the version. And this is because the min pin length that is recently added to the metadata stored on the YubiKey. So yeah, it's also a recent addition to our tools. So that's a good point. It could be that the security key doesn't have that information, but because it's a 5.7.4 security key, it should be there. It's just that the tool doesn't show it. Yeah, yeah. No, that's good. I didn't think of that when writing the exercise, but yeah, you need a recent version. Thanks.
Is it a known problem that we're trying to verify key if you have a password manager that interferes with that?
Ah, yeah. Yeah, so if you, yeah, so there's password managers that also support passkeys. And what they do is so you have this WebAuthn API, and what they do is they install a browser extension, and they steal the WebAuthn API calls and replace them with their own calls. And so the passkeys are not stored in your browser or in your operating system cloud. They're stored in the password manager. And you can disable this, but yeah, if, there should be, so which password manager is this? So OnePassword has a setting. If you go to properties, you can actually say, okay, if you're using a cross-platform authenticator, give that priority and don't interfere there. So that if you use a Yubico or something else, it will actually be stored on the Yubico and not in the password manager. Yeah, yeah, great question.
Is there also a way to do it just like per site, like clicking the little hardware key icon?
Ooh, that I don't know. Also,
I'll check.
could be, yeah, it could be that you can actually configure for this side yes, for that side no. I'm not sure.
Question for the SSH generation. The tool suggests the file name ID something underscore SK, because that's the time in your exercise recommends removing that underscore SK. What's the reason for your name?
Let's see, which...
It's the first line for key generation.
This one?
Using the name blah underscore SK.
Yeah.
This is not the default.
Okay, yeah. So the important thing is the key type. So ECDSA-SK means just like the normal ECDSA, but stored on a security key. And then, of course, you need a file name. But yeah, the convention is to have the file name include the fact if it's a security key. So I didn't. So normally the file name would also be ID underscore ECDSA underscore SK. Yeah. Why is that not here? I don't know. Because I did. Yeah. Maybe it's better if I change that. But it really doesn't matter.
But default file name is also fine.
Yeah, yeah. So if you don't mention the file name, it will create it in the .ssh directory, and then it will have this underscore SK file name convention. Yeah. So it would be clearer if I had that here as well. So I think I'll change that.
In this example, you say to use ECDSA, but not ET25. Is there a specific reason, or should we stick to?
No specific reason other than I want this workshop to be usable by any security key, and ECDSA is a required algorithm for FIDO, and ED25519 is not. So not every FIDO security key has ED25519.
But if it supports both?
And if it supports both, you can choose. And all the YubiKeys, they have both. So for a YubiKey, you can actually choose which one to use. But if you have like, yeah, a security key that doesn't, then yeah. So that's why I prefer ECDSA here.
What if SSH FIDO say that no FIDO security key provider specified?
Then you're using a Mac. And yeah, so that's a good question actually. So what is this message? No OpenSSH provider. What is it?
Yeah, no FIDO security.
FIDO security provider. That is because, as I mentioned, this libfido2 library is used by OpenSSH. And if you have macOS, then OpenSSH is pre-installed, and it's actually a recent version. And it's also a version that supports security keys, except that Apple didn't want to include the libfido2 library because it's open source or something. I don't know. Maybe a licensing thing, but that's a problem. If you want to use the Apple OpenSSH client, then you actually need to compile the FIDO provider yourself. And you actually can do that, but I usually say use brew and install OpenSSH via brew, because that's easier. But some people really want to have the Apple version because it also integrates with Keychain. So you can actually compile it yourself and use the Apple version together with FIDO security keys, provided that you have this provider. But it's a bit of a nuisance in doing that because you often have to update it. And if OpenSSH is updated, then you also have to update your provider. And it's not everyone thinks it's fun. But if you want to do this, I have a script in my gist. Yeah, then you can do it.
For the Docker build thing, I have to copy the public key to the local directory. That's missing now. It's trying to copy that from the local directory installed as Barbing.
Yes, sir.
Key to Docker.
You mean in the Docker file?
Yeah.
Yeah, so the Docker file uses the public key to copy it to the server.
But it's coming from the local directory, not from a .ssh.
Okay, but that's why I had the file name.
Okay, it's a file name. As a full path, I put that file name in my .ssh.
Yeah,
Okay,
you can also do that, but I didn't want to mess with people's .ssh directory, so that's why I stored them locally.
Maybe specify ./ that is.
Yeah.
That it's not only the file
Yeah,
name
that's
path.
it.
Okay,
Good point. Yeah, /.
Okay.
I need to start making notes because now I have 3 things I need to change.
Docker is probably.
Some great questions, by the way. So, thanks. Yeah, question?
I have 2 again. One is the end of keys, just to finish it all.
Sorry, what?
At the end of the keys one, if you also want to delete the rest of the keys from your security key use, stuff.
Can I have a look? So another sentence that I didn't finish. Yeah. Second question.
Second, on the second one for signing, we set up these 2 keys here, but I can't sign using back key. I can only sign using the ED one.
Oh,
But I don't know if that's a mistake for me.
it's my mistake. I actually I used to have this exercise with ED25519 and I changed it to ECDSA.
Okay.
But I didn't remove the command.
Okay.
Yeah, so ignore the ED25519.
Okay, but if I try to sign using ECDSA, it fails with incorrect passkeys. And I've tried moving the mindset as well, just in case. Just in case anything.
Oh,
But it doesn't work with the second one.
okay, then I need to look into this. What the yeah, that's interesting. it's using the agent. You have a SSH agent running. And yeah, and the problem is, so actually that's the last exercise. So if you have the message,
I'm not sure what it is.
yeah, you can just delete all the identities from the SSH agents if that's possible, because otherwise it will ask SSH agent, and SSH agent will have seen the security key backed with your hardware key, but SSH agent doesn't have TTY. So then that's why it needs ask pass to pop up something to ask for the PIN, because you have verify required, which means whenever you sign, use the PIN. But yeah, in short, that's the difference between file-backed and security key-backed keys. The SSH agents will load the private key if it's stored in a file. It will use the passphrase to decrypt it, load it into memory, and then use it whenever it is needed. So if you're signing in somewhere and the server says, you need to sign this, then SSH agent will take over the signing. But with a hardware-backed security key, SSH agents cannot do this because it has to have a PIN. And because it doesn't have TTY, it cannot ask you for the PIN. It says, I can only ask you for the PIN if I have a helper program that will prompt for the PIN and give it to me. And that is the SSH AskPass program. So you need to install SSH AskPass and have a display so that it can use an extern or something to ask for the PIN and then sign it so that you can sign in. So that's actually the last exercise.
Okay, cool.
And for now, I would just remove the keys from your SSH agent or stop the agent so that it doesn't interfere, because then it will complain.
Thank you very much.
Yep. How are you guys doing? Anyone who already completed the first exercise?
Almost. I just wanted to ask why I'm not getting asked for the PIN, but continuing as I have to create the key with the user verification thing.
Yeah, so here's the difference between user verified and user present. You can play with this depending on your use case.
So it's a big part of the key, how it's getting generated, getting asked or not. First I was surprised I have to put a PIN on the key and no one asked me for that, so it's optional.
Well, if you generate a key, you usually have to. Yeah, it also depends on the security key. So this is where it gets complicated, because there's.
Now I have a PIN on the thing and still I can use that key which I generated without the PIN.
Yeah, so you can use the key without the PIN because you didn't specify verify required when generating it.
I have to remember always specifying that flag for generating keys.
Yeah, so if you want to make sure that the key is never used without a PIN, you have to remember this. But if you don't want to remember this, the security key you have, if you look at the FIDO token info, there's this option always UV. And this is not in the exercise yet, but I can add it later. You can say, okay, set this option, which means that no matter how the key is generated, it will always require user verification. So there's no way to generate a key that doesn't require user verification. So some organizations that hand out security keys to their employees, for example, want this to make sure that they don't generate any keys without a PIN. But you can also reset the key and then it's gone again. So.
Can you scroll down a little bit in your example? I think there's 3 command lines at the end of user verification, the little Docker commands.
Over here.
There's a long line.
Oh.
Some of that, or whatever.
Sorry. Yeah. Oh, man. Yeah, so that's a layout thing. These are actually separate commands.
Just insert semicolons, then you can run the document.
Yeah. Probably it's clearer to have separate lines.
Yeah, of course.
Is there a way to set like a time to live on the presence detection so that, like, say you're doing sysadmin and you're going to do 100 SSH connections all at once for Ansible? Like, could you do one touch and authorize all of those?
Yeah, good question. So if you have an automation script which does a lot of signing operations, can you say, okay, I just want to cache the touch so that I touch once and then the other 99 signing operations proceed without the touch? And the answer is no. But if you, so for automation, and actually there's a remark in the last exercise, you could do something with SSH agent. So what you can do is generate a key on your security key, an SSH key generated on your security key that doesn't have user verification and doesn't have user presence. So it's a very insecure key, but then do encrypt it with a passphrase. So normally you don't need a passphrase to encrypt it because the key is stored safely somewhere, but yeah, if you disable user presence and user verification, then it does make sense to encrypt the key files. And what you do then is use SSH agents, and the first time you need to sign, load the key into SSH agents, which will decrypt, in this case not the private key, but the credential ID. But the credential ID is required to be able to sign something, so you need to enter the PIN once, just to obtain, so SSH agent will obtain the credential ID and can then use that credential without user presence and user verification. So the first time you will need to enter the PIN, but in this case only to, you don't enter the PIN, you enter the passphrase. So you use the old way of using SSH agents to then prevent you from having to touch the key or use the PIN 100 times. But it's specific for automation scripts, and you never do this because otherwise one of the big advantages of your security key is lost, and it is that, and that's also in the last exercise where you use agent forwarding. Agent forwarding is a bit scary because if you sign into something that's compromised, they can use your signing keys, and that's why you can use touch or verification to prevent that from happening.
And how many resident keys can live on this?
Good question. I forgot to add that as one of the exercises. So extra exercise. Find out with FIDO2 token how many security keys can be stored. So how many resident keys can be stored. And that depends on your security key. So I can tell you that the security keys, the 574 firmware that I handed out, they can store 100 keys. But all the firmware has I think 25, and I think a Titan key can store 200, but you cannot delete them. So if storage is full, yeah, then it's full.
On that key, I can delete it?
On the Yubico keys, you can delete them, and they can store 100 resident keys. So an infinite amount of non-resident keys and 100 resident keys.
So I have 99 left. So is it shared between passkeys and SSH, the limit?
No, so OpenSSH doesn't have a limit. It's just how many resident keys will fit in memory on the, because if you have your resident keys, then yeah, you have a limited amount of storage. And we have storage reserved for resident keys up to 100 connections.
And but it is shared between, yeah, it's the same between SSH and web and pop.
Yeah. So it doesn't matter if you're using the credential for OpenSSH or WebAuthn or for something completely different. It's 100.
Question about the non-resident keys. I think I do I get to the non-resident?
Yeah, so the question is, what about where are they stored? But I think there's confusion about syncable passkeys and non-resident keys. So if you're using a FIDO security key, it doesn't matter. They're never stored in any cloud. They're only stored on the security key. It's more if you use your web browser on your iPhone or Android device, and you register a passkey there, and you use your Face ID or your Touch ID, then it is you're using a platform authenticator, which means that on iOS the private key is stored in iCloud, and on Android the private key is stored in Android Password Manager, which also has a cloud component. And that is done because Apple and Google are afraid that you lose your passkey, because a downside of a security key is if you drop it in the toilet and you flush it, then it's gone. And then, yeah, if that is if you have like your SSH key in there and it's the only copy you have, yeah, then you have a problem. And the same goes with your Google account. So if you have stored a passkey on a security key and you lose that security key, you can no longer sign into your Google account. And to prevent this, Google says, okay, we'll sync the passkey. So you store it on your Android device, not on a security key. And we make a copy, store it in the cloud, and if you lose your phone, just buy a new Android device and we'll sync that passkey back to the new device. And that is convenient, but of course less secure, because you do need to sign into your account somehow, and it is usually done with the device code that you used on your previous device. So if you have like a PIN code on your device, you can use that same PIN code to retrieve your Google accounts. But of course that is, yeah, not so secure. Less secure than having a non-copyable passkey. But to come back to your question, so resident keys and non-resident keys, that's just about if storage is used on your security key. And if you have a resident key, the answer is yes, the storage on your security key is used. If you use a non-resident key, then actually everything required to restore that private key, to retrieve that private key, is actually stored in the client, in this case the OpenSSH client, in the private key file. Does that make sense?
I just learned that my key is not on the device yet because I didn't have the option resident. Would it be possible to store the generated key from my disk?
Yeah, good question. Can you? So if you forget to make a resident key, can you just fix that by taking it from your file and storing it on the security key? But
security-wise, I don't want to do that because it was
No.
on my disk, or it probably stay on the disk, things like that. But
yeah, but the problem is if you would allow that, then you can say, okay, I have another key and or security key, and I put the same key on two security keys, and then you lose the property that every private key is on at most one security key. So you can actually make clones of your private key. So you lose MFA, for my strict definition of MFA, where you cannot clone keys. And this is actually an important property, because in Europe we have this PSD2, which is for banking, so the Payment Service Directive, which explicitly says if you want to have strong customer authentication, which means that you authenticate a customer in a secure way, they need to have an authentication method that is not clonable. So syncable passkeys are a problem in my reading of that requirement. Whereas passkeys stored on a security key are okay because they're, by definition, not clonable. Or at least cloning resistant. Question?
In the signing exercise, I'm getting how the task pass doesn't exist.
Ah, yeah. So if you get someone complaining about AskPass or SSH AskPass, that is because you have SSH agent running and loaded with some keys. So if you load a key file into SSH agent, normally what SSH agent does is it will try to load the private key in memory, so that you have like a sort of a SSO. But for security key backed keys, that doesn't work, because for every signing operation you actually have so if you generate a key with user verified requirements, it needs to have the PIN.
Okay.
And because SSH agent doesn't have a TTY, it cannot ask for a PIN on the terminal. It needs a helper application, and by default this is SSH AskPass. And to solve this, just remove the keys. So type SSH-add and then -D, which will delete all the keys from your agent. Because what happens is your SSH client, trying to sign a file, asks your agent, hey, I have all these public keys here. Do you have a public key that can sign this file? And your agent says, yes, I have a key. It's an SK type key, and I'll sign it. But then when it tries to sign it, it notices that there's a PIN required.
So what was the command again?
So SSH-add, which is normally used to add a key to the agent. You can also use the -D argument to delete all the keys.
Just so you know, that didn't work for me, and I just gave up and installed AskPass.
Oh, really?
Not get SSH agent to behave.
So then, and if you do a SSH-add-L, does it still list?
They're not there anymore.
They're not there?
I've even moved all my SSH keys out of another folder directory in my SSH folder.
Okay.
It's really weird, but just in case one of the addresses or passkeys.
And are you using something like VS Code or something?
This is there, yeah.
Okay, so VS Code has the same problem, I think.
Oh, really?
Yeah. So if you try from a terminal,
Okay.
because that is at least worth trying.
Yeah, no.
Because I know that VS Code has also issues with SSH. Not if you're storing in a file, but it doesn't. Actually, there was an interesting question on the Yubico Reddit. Someone was complaining about this. And it turns out that VS Code has a really crappy interface to OpenSSH. I can't remember the details, but you can look it up probably on Reddit.
So now I've created the resident key, it's on my token. But I still have to specify SSH-I private key? That doesn't make sense to me.
Yeah, but okay, so the question is, why do I need to specify the key file when the private key is stored on the YubiKey? Because the key file doesn't contain the private key. But it does contain the reference to the private key. So this key handle, the credential ID, that is the only information that is relevant, not the only, but that is stored in the private key file. So the private key file doesn't contain the private key, but it does point to a private key by use of this credential ID. So what happens if you sign something and you specify the private key file, OpenSSH reads that private key file, looks what the credential ID is, and then uses the CTAP protocol to ask the security key, do you have a credential with this credential ID?
Okay, but there's no privacy information in that thing other than the link.
No.
Because it does what I'm expecting. It's asking for the PIN, asking for touching the key, but I was surprised that I have privacy information like this.
Yeah. So there's some more information in the private key file. For example, if you created the key with verify required, so that it knows, oh, I need to ask for a PIN. And you can actually remove that. So you can just edit the private key file, remove that flag. But then it will just do the same thing and fail because it thinks it doesn't need a PIN, but it does need a PIN because the YubiKey or the security key knows that you need a PIN. So it will refuse to sign and then, usually just.
So the text in the actual key file is
Yeah, yeah. So
That's quite confusing.
yeah, it is. I must confess, it is confusing because if the header line in the private key file suggests that it is actually an encrypted private key or an unencrypted private key. But I actually have a tool. I haven't committed it yet because my Python code is so ugly. But I will do that later. I have some code that you can actually parse the private key files. Let me just add it because it's bonus exercise. Because it's actually useful to look at public and private key files and see what's in there. So if it's stored in a file, so no security key backed, then you can actually read the private key. But if it's stored on a security key, you see, okay, this has some flags for user presence, user verification, and a credential ID. I'll commit that in the tools directory. Making some notes to not forget to fix things.
Can I ask a quick question?
Yeah, sure.
What about DSL? We have to run Windows.
So what about Windows subsystem for Linux? You don't need to do that because OpenSSH is available for Windows these days.
Yes, but yeah, the Windows SSH stops. We need to use DSL. We want to.
Oh, you need to? Yeah, but
We need to, but it's much preferred.
yeah, yeah. So what is your question exactly? So
Cannot seem to find the Yubico in DSL.
Ah.
If you're already aware of the issue or how to fix it.
yeah, I actually don't because I'm not a really Windows user, but I think it has to do with UDEV rules. So can you try as root if you like LSUSB or something?
It's not passed through the USB device. It's called SSH command. You have to use BSL to call the SSH.exe file. And then there is no pass through.
Ah, okay. So I didn't know this, but it's about pass-through from Windows subsystem for Linux to the OpenSSH client. Yeah. Yeah. So actually, I have colleagues that have it working, but I'm not very experienced with Windows. So I need to look that up, I guess. But yeah, but it should work somehow.
We have some of our colleagues are not that.
Yeah.
They
Yeah.
don't want change, so
Yeah.
this could be a breaking point.
Yeah. Yeah. So good suggestion because I try to make this workshop doable on any platform, but if I understand it's not really doable now on WSL.
I use a Mac, I had to use Brew, like one mentioned as well.
Yeah. Okay. So
Problem.
I'll look into that.
So which version of DSL are you on? 1, 2? You call the SSH command in Windows from DSL. Okay. We'll try. Is it then SSH.exe? That works.
Yeah. So what is the solution?
So Windows has SSH, or you can install it in Windows. From BSL 2, you can call the executor SSH. The Windows executor, and then yeah.
Okay.
Or you could install some funky tool to allow pass to use the BSL, but that's
Okay. No, I'll just make a note and try to find out.
What was the solution for the last thing?
Well, so many people run into the problem with SSH agent. And the question is, what was the solution? I thought the solution was just to remove all the keys from SSH agent by typing in SSH-add and then option -D. That will delete all the keys that are loaded into SSH agent. But I just heard that that doesn't solve it for everyone. So So are you using an explicit reference to the private key file? So if you're signing, for example, dash capital I sign, if you use an explicit reference, dash F with the private key file, it should just use that and don't bother with the SSH agent. But if you see an SSH ask pass, also try to do it from a terminal and not from a tool like a Visual Studio Code or while signing into another server, for example, with agent forwarding, because then you actually need the SSH agent. I'm not sure if I've answered your question.
Well, using a terminal and I take an explicit reference to FIDO.
And it doesn't work? And did you get the error message in that same term? And SSH add-L doesn't show anything?
What was that?
So SSH-add and then -L. No entities. Okay, then this works a little differently than I thought it did. Do you have a display environment variable? Okay, can you try to, I'm not sure if you want to, but can you try to set it? Yeah. No. Okay, so one other solution, because if you have so this is something from the old days of, or older, it's still there, of course, extern. It uses a display environment variable to point to somewhere to ask for the pin. So if you have a display environment variable set, then AskPass will interfere, or the agent will interfere. Actually, I'm not sure if maybe it's not even the agent. I don't know. But one solution is to unset the display environment variable, because then SSH thinks, okay, I don't have a display, so let's just prompt for the pin here. So someone listening that is truly knowledgeable about OpenSSH might grumble now, but I think that is the problem.
The issue of the residential key command is missing. I'm currently trying to determine how to do it, but I just can't do it. I have access with this key. I don't know. I've tried to place physics into the there's no. Zero is not so based in 6, and then I try to encode the zeros.
So it's actually you need to have this. Actually, no. So what exercise was this? Was this still? Where you're
Keys
trying to?
exercise. At the end of the exercise, it says how to delete it, and then it misses the line, and I tried the last line, and I tried to determine it.
Oh, yeah.
And yeah, right before. In the middle, it says.
Yeah, my fault. So one problem is I forgot to include the command to delete credential here. And another problem is that when you list the credentials on your security key, the output is a little bit cryptic. So there's actually two ways. One is to list all the resident credentials. That is with -R, this one. But then you just see an index and a hash and the application, which is usually SSH. And that hash is just the hash of the application. So that's not actually useful. You need to have this command to list all the credentials specific to an application. And then you will also see a hash, but that's the hash of the credential ID you want to delete. So if you want to use the delete command, use this thing here to look up the credential ID.
GitHub example, there are two more issues. The first one is the curl command. Like curl github.com.keys, there's the, in the readme you have angle brackets username, it's not showing up here.
Oh, yeah.
The username is missing it, and the next one for the SSH, you also need the -A, -I identifier.
Yeah, because otherwise it can't find it.
Trying to get
Let me just correct that immediately because now I have so many issues.
No problem. That's what the workshop is good for.
Yeah, but I thought I did pretty well with the details, but now it's getting a little bit embarrassing.
GitHub is working. Any of those things are working? Others is not insurance. And that username is not showing up.
So why is this? Because this should be further to.
Converted is the wrong way? I have no idea.
Yeah, it's a GitHub thing, I think, because this should be.
You have the sign, but I don't know. Check the line below.
Check the one.
Right. Username is okay. It's just showing up.
So where username does that?
Oh yeah,
Random correct.
the quotes are missing for
I don't know
username.
the name of the
The back quote. In the line below, you see the username is shown, and this is because it's in the back quote being.
Yeah, but I'm using a tab here, which means that
I
this
don't know, only the username or for the full command line, I don't know that one.
let's see if this.
I only can do text and data, not HTML, MP, whatever that is. Maybe just have a look at the browser if it's working like this. I don't know.
And I have the problem that
Because the
I have a different key.
line below is also fine. So maybe more.
let me do this in the browser because my signing key is elsewhere.
And then in line 94, the specified key.
Just a second. Sure. Sorry, and then in line 94?
Yeah, you can only
Oh, yeah.
the SSH command without specifying which key to use.
And that was
Now
ID.
now it's depending on names again, because
Yeah.
if you always use the same one or call that GitHub or whatever. I would
Yeah.
call that key that give it this different name in FIDO. It's clear it's that one I started.
Yeah, actually it doesn't matter if it's public or, and then probably I need to do this because of the angle brackets.
126. Yeah, those two lines don't the red doesn't one line. So sorry, I want 116.
116, 117. Oh, it's big because okay.
Let's see if this is better. Okay, so now it's a little less than that. So. So some people are already in the signing exercise. Is anyone already in the certificate? Large blob exercise? You are? Yeah. Cool. Because I think we're almost out of time. All right, what time? Actually, I don't know. How much time have we left? Yeah, actually, I see we already ran out of time, but I'll be here the rest of the day and tomorrow. So if you have any questions, but you can also email me or use. I'll open discussions on this repo, so you can actually ask questions through the repo. Feel free to ask questions or remind me of more typos, and I'll fix them. And that's very much appreciated because I intend to give this workshop more often. So if you have any other feedback, please let me know. And well, good luck with your security key. I hope you like it.
Thank you very much. Yes.
Thank you.